Alright, so our learning targets for today are to solve problems using properties of spheres and then solve problems by finding the surface area of a sphere. So I first want to point out this over here. A hemisphere is 1/2 of a circle. That's important that we understand that language. So hopefully you look through example A. I want to point out, what do you think was added from this step to here? So if we look at this hemisphere to this one, what were the lines that they drew on, and like why were they important? So if we look at this one right here is our radius. So we know that this distance is also 6, and then y is the radius of our small circle, okay? So that is how they solved this here. So we found y through the Pythagorean theorem. And then once we had y, then we're able to come down here and find our circumference of our smaller circle, okay? Alright, so then if we look at the Trivies A, it's very similar. And so we have the diameter of a sphere is 40. So this right here is 40. A plane parallel to the center of the sphere passes through the sphere at a distance of 12 feet from the center. Find the radius of the circular intersection. So we have to find this radius right here. So then we're going to need to draw in our radius here. Okay, so if we know our whole diameter is 40, then we know our radius is 20. So our radius is 20, and then we have that this distance between them is 12. So you would do the Pythagorean theorem. Okay, so we get 400 equals 144 plus x squared. We subtract 144, and then we take the square root, and we get x equals 16. Okay, so then now we have this radius here, so this is 16, so now we can find the circumference of our smaller circle. Okay, so remember circumference is 2 pi r, so we just plug all that we have in, so we get 32 pi. Okay, alright, so then if we come down here, this kitchen restaurant is really popular with fishermen, and the staff prepares lunches for these fishermen. So basically the containers are these spherical shaped containers, and this is what we're finding, okay? So the formula for calculating the surface area of a sphere is this formula right here. So area equals 4 pi r squared, and r is the radius, okay? So we're just here plugging those in. So calculate the surface area for one spherical container if the radius is 8. So these to go basically spheres, our radius is 8. So we're going to do 4 pi r squared. And then we're going to plug in our radius, okay? So we get 256 pi. Okay. Alright, so then if we look at this one, determine the radius, so this time we're finding the radius of a sphere whose surface area is 1256.64, okay? So once again, we're just going to start with what we have. So area is 4 pi r squared. So we know our surface area, they gave that to us. And we're finding the radius. So we're going to work backwards. So when we divide by 4 pi on both sides, we are left with 100 equals r squared. So 10 is our radius, okay? Alright, so then let's look at the next page. Alright, so each evening the fishermen return these empty containers to this kitchen, and they typically stay for dinner. So the restaurant is an interesting structure. It's a hemisphere on a wooden platform. So remember, we learned that a hemisphere is just, you know, half a sphere. So if we look at number 3, Describe where a plane would have to intersect a sphere in order to form two hemispheres. Explain your answer. So if we think two hemispheres are going to be just two halves of our sphere, so where would you think that the intersection would have to be? So it's going to be at the center. Hopefully you said that, or you said the middle, or you were thinking, or you just sat silently. So it can be cut this way at the center. It could be cut anywhere as long as the center is there. And that intersection, or that plane, is called a great circle. So this is another really important vocab that we need to know, okay? All right. So let's look at number 4. We're going to write a formula for calculating the surface area of the curved surface of the restaurant in terms of its radius, okay? So if we remember, surface area formula that we just looked at is 4 pi r squared. But if we're looking at a hemisphere, that's half a sphere. So if we divide it by 2, then the formula is 2 pi r squared, okay? Alright, so then if we look at 5, calculate the surface area of the curved surface of the hemisphere with radius 10 feet. And this does not include the floor. Okay? So, basically that means that we don't have to add the surface area of the circle at the bottom. Alright, so let's plug in. We have 2 pi r squared, and our radius is 10. So 2 pi 10 squared. So we get 200 pi. Okay? Any questions? Write them down to the side, and then I can help you when I get back. Alright, and then we're going to skip 6 because it's repetitive. Alright, so when you're done with this video, you are coming back to this page and you will complete all of them. Okay, and then I will send out a remind today at 4:15 so you can check them. Okay. All right. So then I want us to look at volumes of spheres. Okay. So we're going to develop the formula for the volume of a sphere, and then we're going to solve problems by finding the volume of a sphere. Okay. So this is very similar to what we've been doing all week with surface area and then looking at the volume. Okay, so I want us to skip to page 530, and we are just going to start at number 8, okay? So we're going to write the formula for the volume of a sphere. So if you were to look at your formula chart or you were to Google it, it would tell you that it's 4/3 pi r cubed, okay? So then if we're thinking, well, what is the volume of a hemisphere? We're going to multiply it by 1/2. Okay, so we get 2/3 pi r cubed. And if you're confused where the 2/3 came from, 2 and 4 divide out, so we're left with 2. 2 times 1 is 2, and then this is a 1. So 1 times 3 is 3. Okay, so that's where 2/3 pi r cubed came from. So this is for a hemisphere. Okay, alright, so then the blueberry bubble, so that's kind of this pancake thing that they're talking about up here. And this is the one that they're talking about. So the blueberry bubble will have a base pancake with a radius of 3 inches, and each of the 6 pancakes in the hemisphere will have a thickness of 0.5 inches, okay? So if we were to draw our sphere, or our blueberry bubble, it's going to be kind of like this. So basically it's a hemisphere, okay? So then when we're looking for the volume of our blueberry bubble, we're going to use this formula right here. So we're going to do 2/3 pi, and then remember our radius is 3, so we're going to do 3 cubed, and you would get 2/3 pi times 27, and that's going to leave you with 18 pi. Okay. Alright, so really all you needed to know from this lesson is this formula and this one, and then it's really just plugging in and can you work backwards and are you able to find all of that. So if we look at number 11, suppose a sphere is divided into 4 equal quadrants. Write a formula to find the volume of 1/4 of a sphere. So if we were to plug this in over here, you have 1/4 and then times 4/3 pi r cubed. So you get 1/3 pi r cubed. Okay, so that would be how you would find one quadrant of a sphere. Okay, and then for this one, I want you to do 12, 13, 14, 15, 16, 17, 18. So basically all of them. And then don't forget that I also want you to go back and do all of these, okay? And whatever you do not finish is your homework. You may work with a partner, but if you guys get too loud, then you will be told to be quiet and you will have to work individually. Okay, good luck and you guys will be fine.